just to test, can you hear me well or some disturbance? Or?
Yes, sir, please.
Can you hear me well?
Yes, sir, we are hearing you. Yeah.
No problem in sound or voice?
Yeah, no problem.
That's great. I want just to ensure there is no problem in sound.
Yes, sir, we are hearing you properly, sir. Yeah,
That's great.
yeah, thank you.
Dr. Goban?
Sir, good morning, sir. Subramanian, sir.
Good
Good
Dr.
morning.
Goban, shall I test the share with you just for testing?
Yes, sir.
So can you see my slide?
Yes, sir, it is visible.
Oh, that's great. That's what I want to know.
Yes, sir, visible. Yes. Thank you.
Thank you.
Madam, whether we can start the program or some of the students also joining, madam. Madam,
ரெஸ்ட் வந்துட்டாரு. நான் உள்ளதாங்க சார் இருக்கேன்.
ஓகே மேம், ஐ வில் ஸ்டார்ட்.
A warm good morning to one and all those who joined with this ICACC 2021 International Conference, the second edition of our conference. I hope the screen is also visible and my voice is audible with all the participants, all those who are joined in the platform. Ma'am, I think shall we start the session? Sir, Gopalakrishnan sir, ma'am, shall we start?
Dinesh audible. I am audible.
Okay, sir. Okay, sir. Okay, sir.
madam,
It's audible. It's audible,
Sir,
yeah.
we can
Yes, sir.
start, I think.
Okay, sir.
Chief
Yes, sir,
guest
yes.
has come.
Yes, sir.
Welcome,
Yes,
sir.
ma'am.
BP admin, sir. Welcome, sir.
Thank you, madam. Welcome.
good morning, sir. This is Dr. Gopal. Good morning, sir.
Good morning, sir. Thank you, sir.
Okay, ma'am. We'll start the session
we start, sir?
with this inauguration of our ICACC 2021 conference. Before going with this conference, and let me give you a short thing about the 2019 conference. It is a second version of our ICACC conference. That is, in 2019, it has happened in the form of offline mode. In that offline mode, we conducted a lot of things, particularly like we inaugurated our skill center in our college. That is the ESIC EEC skill center we inaugurated. That is one of its special kind in South India. So it is only one skill center that is we having in our South Indian region. And beyond with that skill center inauguration, we conducted a job fair, and also we conducted a workshop, and many more things we have conducted in the offline platform. So now with this online platform, so much maximum what else we can, so that things we are conducted this time. So let's we start this second international conference on sustainable environment and civil engineering in this virtual mode, with starting with the invocation.
நீராறும் கடவுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மகதமென நிகழ்வரத கண்டனில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறந்து எந்த செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
With the invocation and the blessings from Almighty, we start the session with a welcome address. I request our beloved HOD ma'am to felicitate the gathering with the welcome address.
Thank you, sir. Good morning to all. Distinguished chief guest, respected guest of honor, vice principal, my dear colleagues and dear students. I extend a warm welcome to all of you to the International Web Conference on Sustainable Environment and Civil Engineering. Why sustainability? This sustainable development may be a generic definition, but it combines many aspects of civil engineering fields. Materials, water, waste management, these are the three key areas that need sustainability in an integrated manner. Sustainability of materials include embodied energy, carbon footprint, conservation of resources, recycling, reuse, green materials, environment impact, everything. And also, building industry is the leading contributor of greenhouse gases, which has been largely occupied by civil engineers. A lack of understanding of the fundamentals of sustainable materials will be the obstacles in implementing sustainable concepts in the civil engineering practice. So we want to have more discussion on sustainability in concrete steel structures in addition to water resources, solid waste management, which are commonly managed by the civil engineers. This conference aims to enhance a strong interest in the sustainability learning and improved learning outcomes in sustainability concepts by allowing the young researchers, future generations civil engineers to analyze various sustainability scenarios and choose the most effective one. In this regard, I welcome our chief guest, Dr. Mahmood Al-Ghazalla, Head of Civil and Architecture, University of Technology and Applied Science, Sheena's Sultanate of Oman. I welcome, sir.
Thank you.
Surely your presence will make more value to our conference. Welcome, sir. And I also welcome guest of honor of today's program, Dr. KVL Subramaniam, sir, Professor Civil Engineering, IIT Hyderabad. Welcome, sir. Thank you for accepting our invitation within a short notice to spare your valuable time. Your presence adds much importance to our conference. Thank you for accepting our invitation, sir. And I also welcome...
Thank you.
Yes, sir. I also welcome Dr. Hemant Gaur, Technical Specialist, Petrofac International Limited, Sharjah, who will be joining after this session. Welcome, sir. I welcome our respected Vice Principal, Admin. Welcome, sir. Without your strong support, this conference is not. Thank you for the support and encouragement by your presence, sir. Welcome. I welcome all the participants who are here to present their findings and welcome all the keynote speakers of today's program. I take this occasion to thank all the delegates who has accepted for reviewing the papers and has consented for chairing the sessions. I am sure this conference will provide a platform to promote various thoughts on sustainability themes in all fields of civil engineering. Also, this conference will facilitate the participants to actively exchange their ideas on diversified topics. And also, I congratulate and thank all our students, staff and convener who have made tiring efforts to bring out this second international conference on sustainability in civil engineering. Once again, I extend a warm welcome to all. Thank you.
Thank you, ma'am. Thank you for your warm welcome with our gathering. So now I request our co-convener of the conference, Dr. Gopalakrishnan sir, to give away the overview about the conference of this ICSE 2021.
Good morning to all the senior professors and chief guest and guest of honor of this function. Again, joining with the head of the Department of Civil Engineering, I welcome you first of all for this program, for this international conference. So we have just 2 months back when we have started our program, but it went very successfully. We have received around more than 180 papers. In that one, we have scrutinized and we have selected some 70 papers for presentation all over the India from various states and also from the various reputed institutions about VIT, PSG and Tyagaraja College of Engineering and so many colleges, and also we received papers from other countries. So we are in the process of publishing the papers with the Scopus Index journals, and it is in the process of making in the route. Actually, today's program, morning we have started with the one technical session at 9 o'clock. It continued up to 9:45. Then morning there will be two technical keynote speech by our chief guest and continued by Dr. KVL Subramaniam from IIT Hyderabad. In the afternoon session, we have again 1:30 to 2:30 structural engineer from Petrofac Limited, Engineer Hemant Gaur is presenting his valuable speech, keynote speech. Then after that technical session start, 4 sessions will be conducting today in the afternoon simultaneously from 2:30 to 4:30 or 4:45. Tomorrow we are having in the morning technical session from 9 to 11 a.m. Then after that 11 o'clock we have Professor Syed Patani from USA and another professor from our group, SRM group, Dr. Segaran will be presenting the keynote speech. And finally we have the afternoon 2 o'clock we will be having the validity address presented by Dr. Kandarao from Central Building Research Institute. So this is the overall program. So total sessions we are planning for 6 sessions and it will be continued today and tomorrow. I thank this opportunity about the opportunity given to me. Thank you one and all.
Thank you, sir. Thank you for a brief overview about the today's and tomorrow's event. Now I request our Vice Principal Admin, sir, to felicitate the gathering.
Thank you, Dinesh. Very good morning to one and all present here. I am very happy and delighted to be part of this one-day international conference on sustainable environment and civil engineering. See, definitely this objective and the purpose of the conference is going to be served to the human society. Now I cordially welcome today's chief guest, Dr. Muhammad Al Hazila from Oman and Dr. KVL Subramaniam sir, Professor IIT Hyderabad. See, today, sir, you are the crown who decorates and added value to this conference. I sincerely thank and welcome both Jains on behalf of our management. See, since principal is on traveling to Trichy, he is unable to join. He wants to convey his wishes to all. Sir, for a kind information to the chief guest and the participants, we EASWARI Engineering College started in the year 1996. Since we are 25-year-old engineering college, we offer 11 UG courses and 6 PG courses along with the research facilities. See, the Department of Civil Engineering always excel in all the fields. Especially, we have a plumbing lab, which is one among the best facilities in South India and also second kind of the entire nation. So I'm very proud to say about the facility what we have in the Department of Civil Engineering. Sir, definitely we are eager to listen and wish to continue your guidance and support always to build a better institution and society. Also, my heartfelt appreciation to Dr. Lavanya ma'am, HOD Civil, and the convener of the conference, faculty members, and my dear participants for this excellent conference and best initiative. See, there are so many conferences are going on. I am happy to share that information is also. There are one more international conference is going on related to networking and communication in our campus. Through again, it is also a virtual mode. So the East Engineering College is always keen to conduct such kind of conferences in the latest trends and the recent technologies. Thank you, sir. Thank you for your participation and your time. I once again welcome for this conference on behalf of our management and my principal. Thank you very much, sir. Thank you.
Thank you, VP Admin, sir.
Thank you, madam.
Words add lot of value. Thank you, sir.
Best wishes, madam. Thank you, madam.
Thank you, sir. I also welcome HOD ECE. Thank you for participating, sir. Thank you, sir. Dinesh,
Thank you, sir. Yes, ma'am. Thank you, sir. Thank you, VP, sir, for your valuable address to us.
Thank you, Dinesh. Thank you.
And to the gathering. And also, I welcome HOD Mechanical, sir. Just now, he is again joining, sir. Sir, welcome you, sir.
Best wishes, madam, and the
Thank you, sir.
conference coordinators for
Welcome.
attendance of the event.
Thank you, sir. Dinesh, sir.
Yes, ma'am. I will let me continue with as our schedule. So now it is a time that we want to release with the proceedings. Actually, in this online and in this virtual mode. So we want to release the proceedings. As usual, our conference is a sustainable conference. Even within 2019 conference also, we only releasing the proceedings in the form of CD. Or in the soft copy form, because to as a word sustainability, we need to follow the things. We are avoiding the paperworks and we are only going with the digital format. So this year also we will going with the same thing, and we will be sharing the digital proceedings to all the participants with the ISBN number. Sir Gopalakrishnan, sir, I request you to just share the front page of the proceedings to all the participants. And also, it will be shared to all the members, chief guests, and other members in the platform. Okay, sir. Thank you, sir. Thank you for sharing the proceedings page in the digital mode. Thank you. Now, let me see a short and brief intro about our today's chief guest, Dr. Muhammad Al Ghazali. He is currently working as a head of a civil and architectural section in engineering department, Shines College of Technology, University of Technology and Applied Science, Sultanate of Oman. And he completed his master's and PhD degree in soil mechanics and foundation, that is a geotechnical engineering. And totally he has 32 years of academic experience, and he served various academic roles like assistant dean for academic affairs, student affairs, and also head of the department. And also in addition to this, he had 7 years of industrial experience, and he published more than 15 papers in conferences, seminars, and in leading journals. And he served various administration roles also, like chairman for a specialization committee of civil and architectural engineering program. And also he is a member of a curriculum review committee for civil and architectural engineering program of Shams University of Technology and Applied Sciences. And in addition to this, he served as an international examiner for various PhDs program in various universities. Even he is also one of a international examiner for SRM IST Katanvattu. So now the platform is for you, sir, to deliver your inaugural address.
Thank you. Thank you, Mr. Dinesh. Thank you, Dr. Gopal, for invitation and giving me opportunity to join you today in a wonderful international conference. I'm so happy to join you today, and it is my pleasure really to join you and to be with you. And I have received last week so many requests for international web conference and even other nations here in the region. I prefer to have your good arrangement in international web conference. Thank you, all of you. Thank you, organizers. Let me just to share my screen with you. See my screen?
Yes, sir. Visible, sir.
Yeah. My paper today, it is latest trends in construction technology. Why the construction industry is so important to any economy in the world, any country. First, we have to study the ancient trends, the present trends, and the future. Question was raised, why the construction industry is so important to an economy. So we, in order to answer
Mohammed,
this question.
sir?
Hello?
Hello?
Yeah, can you hear me?
Mohammed, sir? Yeah, you can tell few words about the conference. Then your keynote speech we can start, sir. We will close the inaugural function. Then you can start your program. Hello?
Yeah, yes, sir.
Dr. Mohammed?
Yes, can you say?
Yes, sir. You can say few words only now. Then we can start the session, sir.
What you want exact? I'm not getting you.
Proceed, sir. Proceed, sir.
Yeah. Can you hear me now?
Yes, sir. We are able to hear you, sir. You can proceed, sir.
Yes. Question was raised, why the construction industry is so important to an economy. So in order to answer this question, first we have to explain why the construction industry is so important. One of the first business developed and virtually all the business rely on our construction industry. People spend 90% from their time indoors, in their houses, offices, companies, universities, schools. Major impact on health and well-being. Total annual revenue, it's $10 trillion per year. So this, it will add value 3.6 trillion, 6% of global gross domestic product. Employ over than 100 million people all over the world. So largest global consumer of resources and raw materials. Population of urban areas increasing by 200,000 people per day. All we will need housing, all they need buildings, all they need offices, infrastructure, services.
Dr.
So,
Mohammed, Dr.
yes.
Mohammed, yeah.
Yes.
Formally, you can say that the conference can be inaugurated. Then after that, we can continue our session, please. So that
you want me to stop?
Yeah, that is, you can inaugurate the conference formally, so that we will formally close the inaugural function.
Yeah.
Then after that, you can,
sorry.
No problem.
Yeah, sorry.
Yes, sir. You can formally say a few words about the conference, Mohammed, sir.
Okay, stop.
Dinesh sir.
Sir, yes, sir. Sir, Gopalakrishnan, sir, I am here.
Yes, sir. You can. KVL Subramanian, sir, you can say a few words about the conference, sir. Then formally we will close the session, sir.
Am I audible?
Yes, sir. Yes, sir.
Yeah. Okay. First of all, I'd like to congratulate the organizers of SRM College for organizing this conference on sustainability with a focus on sustainability. Sustainability is now taking center stage, particularly for a developing country like India, as we are coming out of the shackles of this name tag of developing and trying to contend with being a developed nation. We are looking at developing in a sustainable manner. And to give a little bit of a background, in India now we are looking at a projected growth anywhere from 8 to 10%, and we are currently a $2 trillion economy, and we are shooting to become a $5 trillion economy. Now that will only happen if we make investments in our infrastructure. We have to grow, and grow in a sustainable manner. And what does this growth entail? Well, we're looking at an increase in our industrial production, because that forms the base. We're looking at expanding our agrarian base. We're looking at processing. We're looking at growing to become an export-based economy. All of these will be possible if you have the infrastructure to support the requirement of the industrial growth that we're projecting. In addition to this, we are looking at massive urbanization. For the first time probably in the history of our country and the world, in 2021, we have more people living in the cities than in the rural. So we're looking at a massive urbanization that is accompanying this growth that we're projecting forward, because people are moving from the rural centers to urban centers in search of jobs and better livelihood, which means we have to provide for them. So growth just doesn't entail building. It also entails taking care of rural poor who are migrating to the cities in search of better livelihood. It's not just enough that we provide livelihoods for them, but we have to make sure that they have shelter. So we're looking at mass housing as one of our priorities. In addition to that, providing for water, taking care of the sanitation needs. These all encompass the theme of sustainable growth that we have projected in our vision for the growth of our country. So I think in the India-sensitive perspective or India-centric perspective, sustainable growth is very much required. It is essential, because we cannot just grow in terms of numbers. We have to take our people along and manage this growth of infrastructure in a sustainable way, where we take resources for the projected growth and leave enough for our subsequent generations so that they can also survive and thrive and prosper. So I think this conference is very apt, where we're looking at cutting across different fora, of course, cutting across different silos to look at solutions, because to grow in a sustainable manner would require participation from all fields of engineering. It's not just structures. We're looking at problems related to water, sanitation. All of these have to be an environment, which is a very key factor in this entire growth saga. So I think this conference, as it's put together, brings together, from what I see, people from different areas of specialization. Each one will likely shed light on their perspective on sustainability. I really would like to congratulate the organizers for a very good program. It is apt, and I look forward to 2 days of interesting presentation. So good luck to the organizers, and look forward to this 2 days.
Thank you, sir. Thank you for your encouragement speech. With the note, I thank all the HODs and our vice principal for attending this program inaugural function. Formally, we are closing the inaugural function. Now the session start. Keynote speech by Dr. Muhammad from Sultanate of Oman. Yes, sir. You can start your presentation.
Will I start?
Yes, you can start now. Yeah.
Thank you.
Thank you. Thank you.
Yes. As I mentioned, my paper, it is the latest trends in construction technology. So here we should answer big question, why the construction industry is so important to any economy in any country. In order to answer this question, we need to review the ancient trends, the present trends in construction, and the future trends of construction. Why the construction industry is so important to any economy? It is considered one of the first business developed. Virtually all the other business rely on construction industry. People spend 90% from their time indoors. Major impact on health and well-being. Total annual revenue is $10 trillion. Added value is $3.6 trillion. 6% of global gross domestic product. Employ over than 100 million people in all over the world. It is the largest global consumer of resources and raw materials. Population of urban areas increased by 200,000 people per day. All will need housing and offices and infrastructure services for their our industry is challenged. Ancient trends, I will go for it fast here. You can see this one, ancient trends in using the stone by frame structure, timber, stone, pyramid. They use, even in Egyptian people, they use it in ancient. They introduce these things, and they introduce the timber, Greek people, and they introduce the and form of cement. We can see here as technology, you can see the Egyptian people, they notice the stability of the structure, and they notice to use scaffolding system in that time. So they notice even the mechanism, vertical growth, the vertical shifting the material, how the way they shift the material. And if we compare the ancient and modern as design concept, as shape, as material, is totally different than today. So the ancient, even still some buildings, ancient buildings like theater, Roman amphitheater in Amman, Jordan, my country. And if you compare it up to today, after 2,000 years, still maintaining the acoustic system, protecting, and the material resistant, and everything was designed, was implemented, was constructed in correct way. So even the ancient buildings, they were having good design and materials that they use. And today, if we see the modern design, they use technology in the modern design and the smart technology in the modern design. We can see today different type of material used in ancient and in modern. I will go fast. Even the safety for manpower, it was taken into consideration in the past and today, but now it's advanced, and it is used technology and communication, smart communication, smart technology in protecting safety. So the safety today is smart. Present trends in construction, we have 7 models. First one is building information modeling. So BIM it is already started in all over the world with small projects and big projects even. Virtual reality started, augmented reality, robotics in construction, modular construction, front end construction, sustainable construction, while your conference is focusing in the main aim of your conference is sustainable construction, which is very important today for civil engineering. And our students, they should know how to go for sustainable materials, how to use it, and what is the benefit of using sustainable construction materials. And the latest is the 3D printing construction process. The scope of objectives, these techniques are sustainable. So what I have mentioned are sustainable, are serving your conference, and wide range of application today. If we can see in all over the world, all the countries they start, some countries they are so advanced. All these techniques involve use alternative energy. Can you hear me?
Yes,
No?
sir, you are audible. You are audible.
Okay, that's great. Just I want to ensure that I'm not without sound. Thank you. So let us to go for our civil engineer. Civil engineer has always already adopted new technologies using innovations like suspension system, the building bridge, and GPS. Today we can see the application of GPS and GIS. It is in all over the world. And we can see today even the technology engineering field, while only keep incorporating this new technology and increasing creative way. So our civil engineer, they get creative and they apply in their program goals and objectives and their courses. The creativity and new technologies make our work easier and faster. So this is the benefit of these things, and our civil engineer, they should take care of this. As technologies developed in all the fields in engineering, it's essential to develop new trends, research, and inventions in civil engineering fields also, so that we can minimize the time and the cost and even the effort of humans. Necessity of implementing recent trends in construction industry. Basically, all the traditional codes and books, construction practices are prepared with the view of safety and durability. Safety and durability, that's why we cannot achieve so many challenging construction. But once we break monotony and start exploring new trends, we can achieve the difficulties arising in construction, and when the start imagination into implementation, we can change the world with imagination. So one of the most important model is BIM, Building Information Modeling. It is an intelligent 3D model based on process that gives architectural engineer and construction engineers professional the insight and tools to more efficient plan design, construct, and manage buildings and infrastructure and services. More civil engineering projects with large-scale utilization of the cold technology and big data. Also, the list of innovation is the building information modeling by IM, and engineers can now create virtual models of their design through intelligent 3D model process. This futuristic technology can speed up the time taken to turn building drawing into reality. So before implementing any construction today, you can design it in 3D, you can see all the dimensions, the shape, you can run it, you can operate it, you can use it before constructing, before plotting tender, before constructing. So this is the benefit of 3D. Construction of bridge, electricity, networks, other services. As BIM 3D modeling provides engineers today a chance to visualize completed design and the design process to proceed. the cost efficient. You can reduce, you can change, you can increase, you can replace material, you can replace the shape of your design, and more streamlined in the future. Virtual reality today, it is already implemented. Augmented reality. Virtual, you can see what you design. So as virtual reality and augmented reality models give more information to your eyes, so you can see what you design, see what you draw in 3D. Augmented reality models can be viewed through phones, through tablets, and glasses and helmet. Even in the safety, they are using this. Virtual reality and augmented reality are the newest trends, the latest in trends in civil engineering to watch out for in 2018. And this technology, it is used all over the world now, but they start at least small projects, and in some countries, big projects they are using, and even in safety they are using. Virtual reality, augmented reality here, if you are going for designing in your computer and your drawing, and you design in 3D, you can see what you design, you can edit, you can change. So this, it will give you the opportunity to check whether your selected item, selected shape is correct, corresponding to the specification or no. The proposed swarm construction terminate can build large structure despite having no central supervision. So without supervision, they can work. And these things, it is already started in so many countries, in European countries. Robotics in construction, we can see in demolishing of all building, in soils and everything, and roads and highway. We are using smart machines, smart construction robots. So the robots can be used, and it is used in concrete sewing and in demolishing and in waste, in water and in other parts. Robotics in construction, it is used today in the roads. If we can see here, road paving is a slow process, but with this type of machine road printer, the speed will be very high and accurate, and it will save the time. Robotics in construction, in concrete, you can make the finishing with using concrete. Even you can use here with remote control, and you can, by driving or by remote control, you can use those type of robotics in concrete work. So it will make the work accurate and efficient and faster. Robotics in construction, it is used even in mechanical, in civil engineering, and everywhere. Modular construction. In construction today, we can see the modular. You can design, you can draw, you can design your modular, and you can execute it in the site, and you can assemble all these things in the site, with saving the time and saving the steps of construction technology. The great example of this in Dubai, the 3D office building was printed in 17 days. Within 17 days, they implement one project here in Dubai by going for modularization. So the drones, what's the video function of drones that takes place today? And we can see the drones today, it takes place in the surveying projects, big surveying projects, in construction, in other geotechnical, soil investigation, and everywhere. This system will enable users to align a set of photographs with 4D building method, allow for new models, construction site interaction. So we can see here in the site, we can see where the human, the laborers, they don't have access, and because of the dangerous and hazardous materials, and the drones can monitor these things instead of human, instead of our laborers and even our engineers and our supervisor, our foremen. So the drones can do the work faster and accurate. Drones in civil engineering today, it is used in everywhere, as I mentioned, an investigation of large, where inaccessible site where we cannot access that site, then the drones is necessary to be used. Topography, where is the topography, difficult topography, we cannot access it. So the drones can make scanning and can make data and can explore the photos, and we can explore from those photos the maps, digital maps, so 3D maps. So we can get a lot of information by using drones. So today I can see even in coronavirus time, they are using drones to monitor such things. Repetitive mapping infrastructure. So we can go for sustainable construction material, which comes from source of sustainable materials. So from materials itself, material, once we call it as sustainable, we should take care that today the huge requirement for sustainable energy and sustainable materials. So here, the main resources we have to focus on renewable resources and recycling. So renewable and recycling. So those both, because the materials of construction today is expensive and it is less in some countries, they don't have enough materials, so they have to think in recycling. So this, it comes under sustainable. Principle sustainable construction here, materials. If we make the materials sustainable, then it will help us. So the structure here, we can give the principle within 4 points: structural efficiency, energy efficiency, water efficiency, and material efficiency. Through the efficiency of the structure, efficiency of energy, efficiency of water, and efficiency of materials that used. So we can decide whether it is sustainable or not. The 3D printing construction process by modeling, printing, and finishing. It is not only for construction, even for other purposes. In mechanical, they are using industry, a huge industry, they are using the 3D printing. So here we can see the first project, it was night 5 in French, and within 54 hours they finished it. And we can say the technology for printing physical 3D project from digital data was first developed by Chuck Hull in '84. So the Chuck Hull, he's the father of 3D printing. History of 3D printing, it comes in 26 December 2016 in Madrid, in Spain. Already they execute building the world first. So it was as bridge, used technology of 3D printing. Or even in Amsterdam, 2014, they execute even 3D printing. And let us to go for emerging trends in concrete technology. And this we will achieve it by here, high strength and high performance concrete and self-compaction concrete. Polymers today, we can see the polymers used, it is used with fly ash, and we are trying to replace the cement powder by polymers and fly ash and other sustainable material, while the cement powder represent today as industry a challenge for human health, while the dust affects so many people, even in Jordan and I think even in India or in Dubai here or in Oman, southern of Oman. The cement industry affects the human health around the industry. So we should think as civil engineer how we can replace the cement powder by sustainable material, by new materials, by fly ash recycling, making the cost of the material less by polymers. So reactive powder concrete, and we can see today the bacterium is used in limestone in order to fill the cracks, and the chemical action here. The researchers are also develop liquid to fix cracks, chemical liquid to fix the cracks in concrete and in the structure. So in the structure we are using this bio concrete. It is used today in the bridge, in the road, tunnels, and other concrete structures. So here advantages. Most of these techniques are sustainable. So most of these techniques are sustainable, very less carbon, so it will not affect the pollution. It is not affecting the environment. And all these techniques and technologies use alternative energy. So today we are in very difficult situation while the energy is increasing. So we should think how to save the energy, how to produce energy from other resources than petroleum and other mineral. So here, these technologies is the construction works and very fast and long lasting. So robot swarm again technology can be used in places where access for manpower is difficult. Wherever our laborers they cannot access the site construction site, so the our smart robotics swarm they can use the same job, they can take the same function, same duties. The smart concrete again today reduce water logging, and we can see the future construction building on smart concrete, and drones had made surveying easier, wider, and faster. A plastic road here we can see to solve the problem of disposing it. Disadvantages, as these technologies are new for us as civil engineering, as users, and we can industry people, owners of industry, we can here see the technology are new for all of us and not widely used. The cost is also high. So we should, as civil engineer, to participate in reducing the cost by more research, more implementing projects. We have to prepare some pilot projects in order to study the cost and the properties and whether we can reduce or no, whether we can replace the materials in order to make the cost less and in order to make this industry easier to be available everywhere. These technologies require skills, labors. So this it can be conducted by training. We can offer our laborers and our foremen, engineers, designers who are on the site, who are in the offices. We can offer them training according to these technologies, according to the sustainable materials, according to the usage of these materials. The primary disadvantage of drone use in civil engineering, the essential capital expense required. So it's required, and the 3D printing again are limited. It is not common, and with other countries. So in a few countries they start 3D, but I see 3D printing in so many countries, European countries, USA, Canadian, Japan, Malaysia, so many countries, even UAE here, and Oman, they start. Let us to go for the future trends of construction. The digital future of construction. No way we cannot keep the traditional construction. So we have to move to the digital design, to the digital construction, digital implementation of construction process. So without digital process, we cannot save the time and we cannot make the things faster than traditional way. So people, they are using the communication smart. Cities will be smart. So we need as civil engineers to go for digital future construction. Next generation 5D building will come, and it is already started. And digital collaboration and mobility. We see and today and the mobile usage, smart mobile used in civil engineering works. And our civil engineers, they should learn how to use the mobile facilities in order to make the project management, in order to make the site organized well, to protect our labors, to protect the health. So to save the steps and the construction technology used. So to monitor all the steps by using mobiles and digital smart machines. The internet today of the things and advanced analytics. So the internet can go for advanced analytics. So the industry needs to change. So our civil construction industry should change. Who will change it? The industry people and the civil engineer together, and the students who are learning now, they should participate in this progress in order to make the industry digital, make the civil engineering everything digital, because no way one day will come, everything will be digital. So here the next generation of 5D, we can see here high definition surveying. Today I can see the surveying work in so many countries. It becomes 100% digital, and they are using smart satellite images and smart technology for producing photos, extracting the data from photo, satellite photo, aerial photogrammetry, remote sensing, GIS. No way to waste the time. We need to prepare our engineer, our students, in order to share and to participate the world, the people who are leading this process, in order to help others to come with this application of smart technology used in construction. No way, one day will come fast. It will start today. So our civil engineer, they should start from today. Smart structure. So here we can use, even to study and to analyze and to monitor our structure, we can use smart sensors. We can use smart technology in order to monitor our structure, the beams, the columns, the foundation, the construction under the sea, the bridge under the highway, the airports, everywhere we can use the smart technology in order to monitor our structure related to the behavior, mechanical behavior, physical behavior, chemical behavior, and the strength and the cracks. So we can enable real-time testing for all foundation elements under the ground. So automated or charge payments here in the highway, we can use the automation in order to monitor the usage of traffic, monitor the traffic, the people who are using, drivers, cars, all type of accident, everything you can use it by smart technology. Today, people, they are talking about smart house, smart city, smart services, smart technology. People, they are introducing today and they are producing smart technology. So we as civil engineer, we should come out with our design and to make our design smart, our building smart, in order to match with the technology. If the services are smart, the telecommunication system is smart, and our building is not smart, then there is no accommodation between this and technology. So we cannot be able to use the smart technology. In order the civil engineer to enable them to introduce the smart services in construction, they should be aware, they should investigate, they should learn, should get training, they should get opportunity for training how to use this type of smart services. Today, everywhere is smart. All over the world, they are starting now to build smart zones, smart cities, even industry is smart, technology is smart, services are smart. So why do I need smart home or building? We need it for 4 things: efficiency, cost saving, environmental impact, and user impact. So those are the things that will make the smart design, the smart building, the smart technology efficient, faster, and saving environmental impact and user impact. So those things, they are very important for our future, and no way our civil engineer, our students, they will be involved in this process. Smart cities, we know that Dubai becomes smart today. So all the services now, they start to compare them with smart, from traditional services, traditional buildings, into smart buildings, to get match with the latest technology, smart telecommunications, smart traffic, smart highways, smart water supply, smart gas supply. Even you can open your ACs from so far by using remote, by using satellite. So you could use the system of telecommunication, and you can control your house. And that's why we call your house as a smart home. So the smart home using the smart technology. The smart home cannot be smart unless the design is smart. The building, the way how we build it, everything in the house should be smart. So our civil engineer, they should start. No way. So the future for smart cities is now. Problems in the world will never end or diminish. They will simply evolve and grow. And however, if the cities around the world share their ideas, goals, and dreams, then we can learn, students and engineer, civil engineer, mechanical engineer, electrical engineer, they will learn how to resolve those channels together. this is type of smart cities proposed. This is the way how GIS can help us today in offering us digital data where we can use this data and let us to say and layout of our services. If I am director of municipality, if I have GIS system, I could see in my screen all my construction projects under construction. Those projects they require from us as civil engineer data, and they require services to serve people who are having their building under construction. They need roads, they need water supply, they need other services, networking, internet, other things, gas supply, water supply, drainage system. All these things we can convert all our services in smart in the digital map. So we can convert our services on digital map. We can see what we are serving people. We can plan for our work within 1 year. How many houses we can serve? How many houses we can offer them drain system? How many houses we can offer them green area, schools, clinic, whatever we need. By using geographical information system, the civil engineer can use the technology, can use the latest technology in designing the services and choosing the best layout of the road, choosing the best place of the dam, choosing the best place of the airport and other projects, big projects here. So smart technology, should these technologies change the way we design, the way we build cities? And if so, how? This question raised to all civil engineers. They have to start to think in order to participate in future in designing and planning and designing and implementation of smart cities. Smart buildings, digital construction industry, today requirement, to tomorrow challenge. It is wrote by me, Dr. Mahmoud Ghazali. Thank you, organizer, for great international work conference. And I am so happy. It's my pleasure to join you. And I thank the audience. I thank the participants. I thank the organizers. I thank everywhere. I thank Government of India for giving me this opportunity. Thank you, sir. Thank you, Dr. Gopal.
Thank you, sir.
Thank you, sir. Thank you for your brief latest trends presentation, and also your presentation gives about a lot of things about the smart buildings and other latest technology which is evolving in the construction technology and construction industry. So thank you for being with us, and thank you for being with SRM EASWARI Civil. Thank you, sir.
Thank you, sir. Thank you, sir.
Sir Gopalakrishnan, sir.
Yes, sir. Thank you once again for Dr. Mohammed for coming over here, for giving a wonderful speech about your presentation. Through your presentation, it is encourages for our students also. Thank you. We will further collaborate with you and your university for future programs. Thank you, Dr. Mohammed. Thank you once again.
You're welcome. Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you.
So, following with Dr. Muhammad Al Ghazal sir's presentation, that's after its end of this presentation session, like the today's requirements with this tomorrow's challenge, we'll go with the next presentation, that is the next keynote speech by KVL Subramanian sir. So, I request Gopalakrishnan sir to introduce KVL Subramanian sir to the gathering, and then he will continue with his session.
Yes, sir. Yes, sir. Yes, good morning to all. I am very humble privileged to introduce Dr. KVL Subramaniam, Professor, Department of Civil Engineering and former Dean, IIT Hyderabad. He has the teaching of experience more than 15 years, and he is having publications, more than 100 publications in his hand, and he has been awarded for the Teaching Excellence Award from IIT Hyderabad. This is the award for excellence in teaching by the American Society of Civil Engineers Faculty Award, and he is the research, he is the coordinator, and he is having the scholars, more than 15 scholars completed in his own. He completed BTech Civil Engineering from IIT Delhi. He completed MS Civil Engineering from USA, and same PhD Civil Engineering from USA also. He was the Dean Planning and Development for the year 6 years in head of the Department of Civil Engineering also for the year 2010 to 2015, and he worked as a professor in University of New York Civil Engineering Department also. He was the Director of Civil Engineering for his PhD program for 2009 to 2010. It is very privilege and very honor for being here, Dr. Subramaniam sir, as the keynote speaker for this international conference to sustainable engineering, civil engineering. Now I request Dr. Subramaniam sir to give the keynote speech.
Thank you, Dr. Rajagopal. It's indeed a pleasure to be presenting here, a topic that is quite dear to my heart. I like to start first by sharing my screen. Yeah, so hopefully my screen is visible now.
Yes, sir, visible, sir, visible.
So let me just go into the, yeah. So now hopefully it's in the presentation mode. Sorry. Yeah. So what I want to talk about today, me, is about sustainable high-performance concrete. So, I work extensively in this area of concrete, and I think previous speaker has laid the groundwork. We realized that achieving sustainability in concrete is actually a major challenge because of several issues that are related to carbon footprint, the energy, the raw materials, etc. So what we need to do is to develop a concrete which delivers high performance. So if and this requires a change in our paradigm of thinking, because as civil engineers, we conventionally think about only strength. That's how we are trained, and even today we continue to train our students in concrete as something that should be designed for a high strength. But I think we need to change our focus, start looking at high performance if we want to be sustainable in the long run. So just to give you a little bit of a preview of where I'm headed with this thing, this is the skyline of what we have been constructing over the years. So starting from 1930, which is to the extreme right, is the Empire State Building. And the current tallest building, of course, is the Burj Khalifa, which is in Dubai. It's about 800 plus meters in height. You can see, of course, it's that the heights of the buildings have been steadily increasing. There's no doubt that we are pushing the envelope. We are overcoming the obstacles that are imposed by nature, literally working against gravity and growing taller and taller. So, of course, this cannot be achieved unless we are able to produce improvements in materials, material processing technology, and deliver materials at the heights that are required to be able to complete the construction of these structures. Now, the other thing that is I'd like to point out, which is probably which goes unnoticed in this whole thing, is as we move from the right and start to the left, we start seeing that somewhere around 2000 is where concrete started entering into the picture with this high-rise and super tall building. So once we start moving to the left of Taipei 101, we start seeing concrete entering into the structural framework of this building. So Petronas had majority concrete, but then by the time we come to Burj Khalifa, the structural system is predominantly concrete. So now we are able to produce concrete, gives us the required strength, it gives us the required performance, because for this tall building, there are several severe performance requirements the material has to meet, and we are able to deliver the material at that height. Now I'm able to deliver concrete at 800 meters height, almost a kilometer in height. That means we also have delivered delivery systems. We also have developed delivery systems which allow us to now take concrete to that height. literally take concrete to a great height. And this has happened because of tremendous development in technology that has taken place in the last 30 years, and also a change in the way that we are visualizing concrete. So, with that background, let me move forward. And this shows you where we stand with the current talls and the super talls. If you look at the new super tall buildings, the super tall buildings are those which are, if you put them as the top 100 buildings in the world, 59 of these are in Asia today, and 23 are in the Middle East, which only leaves 18 in the rest of the world, which means in terms of action, in terms of real development, it's all happening in Asia, Southeast Asia, and Middle East Asia. So this is where most of the development and action is. The other thing is that if you look at some place like Dubai, let's say, which is happens to be the where the high-rise buildings and the super talls that dominate the skyline, 93% of these new super talls are made of concrete. If you look at the next, the two tallest buildings, the Burj Khalifa, which is about 828 meters, and the new tallest skyscraper that is coming up, the Jeddah Tower in Saudi Arabia, which is going to be 1 kilometer tall, both of these super talls use concrete structural systems. So that basically has happened because of this tremendous advancement we've been able to achieve with the material, with the use of the material. Moving forward now. Yeah. So this is just another bar chart that shows how buildings have changed over time. If you look at 1930s, which is the bar at the extreme left, you see that 98% of the super talls of 1930s, or the tall buildings of its time, had steel superstructures or steel structural systems. As we move to the right, somewhere around 2000s, you see that the steels occupy only 40%, and the remaining concrete is gaining ground to the point that when we come to 2018, almost 60 to 70% of the super tall market is now concrete. And again, I keep emphasizing this, but that has happened because of the long-term the advances that we've made in terms of concrete strength, pumpability. Now we can pump concrete, and I'll illustrate some examples later. We can pump concrete now to 800 meters to a kilometer in height. Affordability, of course, in terms of comparison in cost between steel and concrete, concrete is definitely coming out as a winner. Advancement in construction techniques. Now we are talking about techniques like 3D printing, which allow us to basically form concrete on site without the need for formwork or any shuttering, which really speeds up construction. This coupled with the advantages that you have in concrete, that is durability. Concrete is a durable material if it is done right, and high endurance against fire. It has a high, a very good performance in fire. It is concrete that is now emerging as a champion when it comes to buildings and, of course, high-rise buildings in particular. So, what are these advances in concrete that have taken place that allow us to now push this material as the material for the next generation? Well, one of the important innovation that has happened is the building system. Now we are talking about composite construction. So this composite construction is coming forward in a big way, where we take advantage of steel and concrete working together. And now with the composite action between steel and concrete, different forms are visualized, structural forms are visualized. And in this composite construction, where steel and concrete is mixed together, the load carrying capacity and the stiffness can be increased by a factor of 2 and 3.5. That means I can basically produce a stronger system, a stiffer system, which at a lighter weight. So that is the advantage of this composite construction. And we now see that more and more in buildings, this composite slab system being used. One of the advantages is that the steel, which also serves as reinforcement, basically provides me a working surface on which I can place my reinforcement and pour concrete onto that. Now the advantage is because it's composite, I get a lighter structure. I use less steel, less concrete. At the same time, it's a very stiff structure, so I get reduced vibrations and I get higher fire protection, which is one of the biggest problems we have with steel structural elements. And of course, with these composite constructions, different forms are conceived, where now we're thinking of bringing in reinforced concrete coupled with steel structural members to produce these nice stiff configurations. Basically, One of the biggest advantages of this composite construction is that we are able to enhance the fire resistance, which is a big challenge when it comes to high-rise buildings. Of course, we can prevent the crippling local buckling of the steel members, which tend to be quite thin, so they are prone to these kind of failures. We basically also are able to prevent lateral torsional buckling of these steel beams. These are all typical problems associated with conventional slender steel beams, and increase the stiffness of this construction. Therefore, we are able to make a lighter structure stiffer and stronger. Now, in bridges, of course, this composite technology has been used for a while. The medium span composite bridges are normally constructed using a steel girders with a concrete deck integrated in different ways. And these designs have all been standardized. So this is basically a little bit of introduction or talk about composite construction, where concrete is now being brought in to work with steel to develop these structures, which are lighter and stronger and also stiffer. But in concrete itself now, we're talking about pure concrete structures, but there is a change that's happening. There is a paradigm shift that's taking place. In concrete now, we're talking more and more about performance-based design. Now, conventional method, if you look at the conventional method, the way we've done things, it's always been prescriptive. So we basically prescribe a requirement of strength. All our design codes, the way we design our concrete structural elements, are based on strength. So we basically prescribe a concrete material strength. We require our structural members to have some capacities in flexure, shear, etc. So where is performance-based design difference? In performance-based design, the methodology, basically here, the structural criteria are expressed in terms of achieving performance objectives. We don't prescribe things. We basically only define performance objectives and let the designer provide the design that meets the required performance objectives. So when it comes to meeting performance objectives, we are looking at performance during formation. Now, this has become a very important thing. How is concrete performing while I'm placing it? Now, even that has become very, very important, because if you look at pumping concrete to 800 meters, there is a specific requirement. The concrete should be able to withstand the pressure to be able to be pumped to that height. So performance during formation, during placement is in itself become quite important. And of course, performance during service life is that I want structures to last long. And that's what would make this material sustainable. If I can build a structure that lasts up to infinity, then there is lesser requirement to replace the structure. That is sustainability at its core. So when it comes to performance-based design and performance-based specifications, now from materials perspective, we start specifying things like formability. How formable is the material? Placement and speed. How fast can I bring the material to place it, and how fast can I finish it? And of course, long-term durability is how durable is the material. I want the material to be durable up to infinity, ideally. Now, in terms of performance-based specifications, structural performance, these have already been codified. These have already come into the code. Now, when we talk about seismic designs, we talk about ductility, and this performance-based design on requirements on ductility. These have already become quite accepted and have also been practiced. But from the material perspective, this unfortunately has not yet been implemented. And I think now it's time that we are starting to look at this material perspective and look at performance requirements of the material as well, in addition to just saying strength is all that is required of this concrete. So, so when I talk about what is the expectation of this high performance concrete, well, I want concrete I want to specify concrete in terms of its performance in the fresh state and the hardened state. In the fresh state, I'm looking at properties like flow, pumpability, filling ability. I'm looking at all of these things. And of course, the performance from the hardened concrete would depend upon, in addition to strength, the long-term durability. Now, if I hit all these parameters of performance in the fresh state and in the hardened state, what I get is an assured performance from the structure over a long period of time. That means the structure will be performing at its prescribed level of performance. It will be usable for a very long time. And that is what we are now heading towards. Just to give you an idea, this is the Union Square building in Seattle, where of course a very high strength concrete was specified, but For the first time, they specified the modulus of elasticity of concrete. Now, this is not something that is very typical in specifications of concrete. The reason high modulus was specified independent of the strength was because if you increase the modulus of concrete, you can actually make the concrete, as you make it stepper, the deflections of the building would be decreased. So this is one of those specification requirements that has been put in place for concrete. Now, there are other such examples that are now coming forward. So, and I want to take the example of the superstructure of the One World Trade Center. The kind of specifications that are put in place for concrete that went into this One World Trade Center was that less than 236 kgs of cement could be used per cubic meter of concrete. Now, this is a very severe requirement. Most of us know that 236 kgs of cement per cubic meter of concrete would basically probably hurt strength. But they did not compromise on the strength either. They said in columns up to 40 floors, concrete had to achieve 80 to 95 megapascal strength, and the upper floors the concrete had to achieve 60 to 70 megapascal. So you see the way the specifications are being put in place, where the specifications are put in place in terms of achieving a target of strength. Whereas if you look at the way things are done in our code currently, we specify how much cement should be used, what should be the composition. All of these things are specified. Now here, we are not, nothing was specified in terms of what should be used. What was specified was the maximum amount of cement. So that was severe limitation that was put in place. The other performance requirements that were given were that concrete had to achieve a flow of 600 to 710 meters. That means the concrete had to be very flowable, and the concrete had to have the ability to pump for at least 15 floors for the 95 megapascal mix, and it should be able, it had to be pumpable up to 40 floors for the 80 megapascal mix. So this is a performance specification on the fresh concrete that is being put in place. This is the requirement that it had to meet. The maximum heat of hydration was specified at 70 degrees Celsius. So these are performance specifications, performance requirements and specifications that are put in place. Now, how the contractor achieves these specifications and these requirements is left to the contractor. There is no hand-holding that is done in terms of telling the contractor how much cement he should put and how he should go around doing it. So this is now the new things that are coming up where we insist on a performance. And here the performance requirements are specified in terms of ability to pump. So that is becoming very, very important now. The height to which we can pump the concrete is now being specified. And in this particular case, the maximum heat that the concrete...
Sir, 1 second.
Yeah.
Sir, some people are unmute. I want to mute the people.
Participants, please unmute. Unmute your audio. Sorry, mute your audio.
Yes, sir, you can proceed.
Okay. So now going forward with this high performance concrete, and I said now we are looking at concrete performance specifications in terms of performance when it is in the fresh state and also in the hardened state. So when it comes to delivering the performance, I have to engineer the material. So now we are paying a lot of attention to how to engineer the material so that we can deliver the required performance. And how can I now engineer the performance of the material in the fresh state? The requirements that I should be meeting. There's a constant background noise. I'm wondering if...
Yes, sir, we are trying to do.
Dinesh Kumar sir, please unmute all the participants, sir. Dinesh Kumar sir.
Okay, ma'am.
Okay.
It is muted, sir. You can continue.
Thank you. Thank you. So now we're looking at to deliver the performance from the fresh concrete, I have to engineer the material. Engineer the material to meet specific requirements of pumping. Like what I showed in the previous example, if the concrete has to be pumped 40 floors, the concrete should be able to withstand the pressure, 40 to floors would mean that I should be able to pump concrete for a height of at least 120 meters. That means it should be able to withstand a pressure head of 120 meters at the very least. So that means that now I have to engineer the material so that it can be pumped. We are now talking about self-leveling, self-consolidating requirement. That is, I try to fill the formwork without the requirement of vibration. This makes it possible for me to achieve intricate shapes and reduce the labor requirement on the site. Formless placement, of course, is the final final leg of this chapter, where if I can make the material, I can engineer the material so that I can print with it. That is formless placement, where I don't need formwork, I don't need shuttering. That requires ultimate level of engineering of the material. And of course, this is the engineering of the fresh state of the material. So these are the kind of performance improvements you are bringing about in the material itself by engineering the material. So now, just to show you the placement requirements, the pumping requirement of concrete in Burj Dubai Tower was about 601 meters, where a pumping height of 601 meters was achieved. So that basically meant that concrete mixture proportions had to be developed such that the concrete could be pumped to a height of 601 meters. It can withstand the pressure of the pressure head of 601 meters as it's being pressured to lift to that height. So that is a performance requirement now, and these are things that are becoming more and more important in modern day construction. Similarly, in one World Trade Center, the concrete was pumped up to for a height of 103 stories in a single lift. So these are now becoming more and more important in an effort to make to speed up our construction, in an effort to reach greater heights with this material. So that is one requirement of high-rise buildings. There is also a requirement of concrete performance in formation. Now, in order to speed up pavement construction, we are developing stiff engineered mixes. And these are paver machines, which basically essentially extrude concrete pavement. As you can see, as the machine moves forward, it is extruding a layer of pavement. There is no formwork that's involved. This form of construction is very rapid. But of course, I can't achieve this till I am able to deliver on the performance of the concrete. The concrete has to have a zero slump. It has to have a shape retention. And I can only achieve this kind of performance from concrete by engineering the materials. That's where a lot of work is going on in terms of engineering the fresh performance of concrete. Other requirements of fresh concrete performance in formation is in precast technology. So these hollow core slabs that you see here, they're basically made out of using an extrusion kind of a process where concrete is extruded, and as it is extruded, it is extruded with these holes. And after the extrusion, after the concrete comes out of the machine, those holes have to keep their shape. There's nothing holding those holes in shape. The concrete by itself is stiff enough that it's able to retain the shape of the holes. If the concrete is not stiff enough, if it does not have the proper consistency, those holes will collapse, and I will not be able to produce the hollow core slabs. So this again requires engineering the concrete, engineering the fresh performance of the concrete to deliver this kind of performance. Where the concrete stays stiff, I'm able to extrude it. That means it's able to flow under pressure, but as it comes out, it is stiff enough that it keeps its shape. So this is again another example of formation of concrete and performance requirement of concrete in the fresh state. And of course, if I stretch it now, the next step is 3D printing. If I can now perfect this art, then I can start building my structures by printing them, giving them the shape by depositing layers, and that's typically how concrete printing is done. Now, in terms of concrete printing, you see the slide on the right-hand side here. We're currently looking at extrusion-based concrete printing. So here, we build a structure layer by layer. So we discretize the entire structure. So you look at a CAD drawing of a building, we break it up into layers, and then we assemble the structure by adding one layer at a time. So that of course again requires a tremendous amount of engineering of the material so that I can achieve this kind of flow that I need when I pressurize the material, and it should come to a rest and it should keep its shape. So that requires again a lot of engineering of the material, playing around with the composition to deliver this fresh performance where it is able to flow under pressure, where it comes to rest and keeps its shape. And it allows me to stack layers one on top of the other. And by stacking multiple layers, I'm able to assemble the entire structure. So all of these things, when it comes to managing the fresh state of concrete, essentially comes down to engineering what is known as the rheology of the material. So rheology of concrete is something that is becoming very, very important. Where we are now looking at controlling the rheology. I should be able to control the flow properties of concrete. By playing around with the rheology, I can produce concrete that flows like water, and you see that self-leveling, consolidating concrete or self-compacting concrete being produced here. This is concrete that flows like water. It fills the formwork under its own weight. There's no need for external vibration. At the end of the day, I'm able to achieve a concrete which is as strong and as durable as a concrete that is produced conventionally. On the other end of the extreme, where I'm getting into digital manufacturing, I need concrete to flow under pressure, and I should be able to stack layers, basically put one layer on top of another and build an entire structure. It's the same concrete. I still achieve the same strength from the two. It's just by playing around with the composition, by adjusting the composition, I'm able to vary the performance of the concrete in the fresh state and achieve the performance requirement that I need in the fresh state. So the little tangent here is that about 2 decades ago is when we started realizing that we need to get into this domain of rheology control. And the first few experiments were to look at this self-compacting concrete, or SCC. And the need for that came about because we were looking at placing concrete in reinforced concrete structures with very heavy steel congestion. And our conventional knowledge of concrete at that point of time was to make concrete more flowable by adding water. And the way we measured concrete flow was by conventional slump. And soon it became obvious, as I'm showing you this example, that when you have heavy steel congestion, just making concrete of a high slump won't do it. Concrete will not penetrate through all the small gaps that you have with very tight reinforcement. That's where people started realizing that now flow has to be looked at. We need to look at the flow behavior of concrete, and slump does not provide a solution, or it does not indicate anything about the flow of concrete. More examples of structures. This is a pile. This is a cast-in situ pile. Here we put a reinforcement cage into the ground and then pour concrete. And you can see concrete did not penetrate through the reinforcement cage. So again, here, slump is not the solution. People started realizing that we need to get into self-compacting concrete that flows under its own weight. It's able to fill all the gaps, go through the small gaps in the reinforcement. And that's when SCC was born. And the same girders, the precast girders, which were made out of regular concrete previously, had large honeycombs and voids, are now produced with SCC, and you see the beautiful finish. Concrete of the same strength was achieved, so the strength was not compromised. But by engineering the performance, the fresh performance, the flow behavior of concrete, we are able to achieve a concrete structural element that is now free of defects, therefore it will last longer. So that is the underlying principle of delivering on the performance of the concrete. Then self-compacting concrete or self-consolidating concrete has become quite commonplace now. We're using it to produce what is known as form finish concrete. This is concrete that can be used immediately after removing the formwork. Plastering is not required, so I save money on the requirement of plaster. And I get nice, beautiful finish of concrete, which looks like an artificial stone or sometimes even a natural stone, which basically also minimizes the need for paint on the surface. So on net, there is a saving, and I get this structure that is long-lasting and, of course, reduce my requirement for maintenance. Now, if this video works, I can show you what self-compacting concrete looks like. So this is the typical SCC mix. We have on our campus done a lot of form finish concrete that basically has not been plastered. So you see, this is an SCC mix that flows under its own weight. Less labor is required because now we don't need to vibrate or consolidate the concrete. It flows under its own weight. You can see the concrete flowing under its own weight and filling the formwork. So basically the concrete flows, it uniformly fills the formwork. I get beautiful finish of the surface when I'm done with this. Minimize the labor requirement, minimize the requirement for plastering, paint, and other surface finishes. And net, I'm able to achieve a long-lasting structure by engineering the performance of this, fresh performance of this material. So now the next step is to look at performance of concrete in service. We looked at the performance requirement of concrete while it is in the fresh state. But we also want concrete structures to last long. So therefore, we're looking at high performance concrete in service. If I can produce a concrete which delivers good performance over a long time, that is, like I said, the very definition of sustainability. Just to give you an example, this is a structure that was built 2,000 years ago by the Romans. It is bottom on the top here, and it is still in use today. So this is a model of sustainable construction. And how do we achieve this? We can make structures that deliver on their performance. That is, if the structure built today, even after 200 years or 300 years, is still able to deliver the level of performance for which it was designed, then that is a serviceable structure in the long run, and that is sustainable. How do I achieve that? I have to now look at, for a long-lasting structure, I have to look at enhancing the durability of the material. So this is, when we're talking about high performance in service, when we're talking about high performance of concrete long term, we are looking at the durability requirement of concrete. Now, high performance concrete in service is now becoming more and more reality. We're not starting to look at specifications for performance from buildings, and now it is being specified for use in different environments and different structures like tunnels, bridges, and of course the conventional buildings, etc. So high performance concrete, the way we define it is concrete that has been designed to be more durable and if necessary stronger. So strength is not the key thing here, it is the durability that is required from the concrete. So we are looking at concrete which has 55 megapascal or higher, which is basically the definition of high strength, anything that is stronger than 55 megapascal, but it has been proportioned or engineered to provide strength and durability. So these are the two key things that we need to achieve to get a high performance concrete, which basically would ensure that we have a long lasting structure. High performance concrete in service, of course, now I need to change the specifications of concrete. Now I cannot insist only on strength. I basically have to look at performance measures of hardened concrete. I need to look at performance measures like strength and stiffness. I need to look at long-term durability. I need to specify what kind of durability do I expect from the structure? What is the durability measure that I need to put in place? But of course, conventionally, the way we have done specified concrete is by prescriptive measures in our current reports. We specify a maximum maximum cement content. We specify, we put limits on water to cement ratio. We put limits on the supplementary cementitious materials. But these are all prescriptive measures. These do not assure performance. So now what we're saying is that we need to look at performance and specifying performance. Let the person who is delivering the concrete, let them assure the performance. By what means they achieve the performance is left to them. We do not specify, we do not put prescriptive measures in place. One of the challenges with having a performance-based spec is how do I evaluate performance? If I need to check something that is to last 200 years, how do I test it today and assure its performance in 200 years? So that is one of the major challenges with this performance-based specification of concrete. And now a lot of work is going on developing these test procedures, which are accelerated test procedures, which give us results in a short time, but which allow us to extrapolate the performance of a structure over a longer period of time. So again, now people are starting to relook things where traditionally we have looked at 28 days spent. Now, if I look at a high-rise building, suppose I have a high-rise building that I'm constructing, where is the need for me to specify a 28-day spent? Because if I look at the columns at the ground floor, by the time they see loading, which is substantial, the age of concrete would be definitely more than 28 days. So why is there a requirement for concrete to achieve all its strength very early? So we are looking at now prescribing strength requirements more on a 91-day requirement or a 56-day requirement, which basically relaxes this rush to gain strength and which allows us to use more supplementary cementitious materials, basically materials like fly ash and slag into the concrete. It reduces the heat generated in these structures. And basically, I'm able to produce more durable structures with the use of these supplementary cementitious materials. So there are different test procedures, like I mentioned, that have been developed for measuring different things. So if you look at this left-hand side column, that is the property being measured. We are all very familiar with the strength. That is the very first row. But if you come down here and you look at the blue box, these are the performance measures, the long-term durability measures. And now accelerated test procedures have been developed. And now we can specify performance of concrete in these tests and say concrete should be able to achieve this level of performance in chloride penetration test, which would assure that if you put that concrete for use, let's say in a marine environment, it would be able to withstand 200 years of service life. So this is the kind of requirements these are the kind of requirements that are going to come in place, where now we will specify the performance requirement of concrete, which will ensure a long-term durability of the structure. And the material palette that we have to use now has also expanded tremendously. Because now, conventionally, if you look at it, we only had Portland cement. But now we are bringing in more and more supplementary cementitious materials, fly ash, slag, calcine clays, metakaolin. These are all finding their way into cements. And our admixture basket has grown tremendously. Now we are using different types of admixtures. We're blending admixtures so that we're able to specifically target or target specific improvements in performance of the concrete. So just to show you how this could be achieved, I'm just showing you the performance of concrete against chloride penetration. This becomes very, very important when we are dealing with concrete in a marine environment. And the test is done by the ponding test, the ASHTO test, where you pond concrete with the salt water and you see how much chloride penetrates into concrete. Now, this is a control concrete, which was basically designed using OPC. But now the same concrete, when it was designed with GGBS or fly ash, the strength was kept the same. So we achieved the same strength with the use of GGBS and fly ash. But you notice what happens to the chloride profile here. The chloride profile is much sharper when we use GGBS or fly ash fume, which means chloride is not able to penetrate as easily into this concrete made with fly ash or GGBS as compared to control. Now, which means, of course, that if I use this concrete in a marine environment, it would last much longer. And therefore, I would get much more durable concrete in that situation, which would ensure a longer service life of the structure. So just to show you how specifications are being put in place, we have now specifications of concrete in terms of strength. This is a typical high-performance concrete bridge deck specification. And in addition to that, you see here an RCPT value is prescribed. RCPT is rapid chloride penetration test value that has been prescribed, saying that the concrete that goes into this particular bridge deck should, of course, meet the strength requirement. But it should also meet this requirement of having a low chloride penetration. And that would ensure that chlorides cannot get through and steel would not corrode. And that would ensure a longer lasting bridge deck. So this is about performance-based requirement and longer lasting structure. Now, the last thing I want to talk about is we talked about high performance concrete, but of course now we're stretching the envelope and we're talking about ultra high performance concrete. So it's not just high performance concrete. We want to push the envelope and develop concrete which delivers extremely superior performance in both strength and other performance measures. So this is a range of typical performance measures that we expect from something that is labeled as ultra high performance concrete. Look at the compressive strength. We're talking about compressive strength basically on an average around 200 megapascals. So it's extremely strong concrete with a very high modulus of elasticity. But more importantly, if you look at the chloride ion diffusion or the carbonation resistance, the freeze-thaw resistance, the creep and shrinkage, these are all extremely superior compared to normal concrete. So this is a concrete that delivers on a performance at a very high scale. But of course, this very high scale performance comes at a cost, because you cannot deliver this level of performance without improving not just your material mixture, but also processing, because ultra high performance concrete requires high level of processing, and that adds to the cost of the material. Now, what kind of performance can I get? This is the kind of performance I can start getting from ultra high performance concrete. This is a concrete that basically would be extremely ductile. Basically you start getting a very high tensile strength, you start getting very ductile behavior from this material. Just to show you a comparison, this is a regular reinforced concrete beam. So what you see here is a regular RC concrete beam, which has been designed for achieving a certain strength over a certain span. So this is the photograph of the beam. The same beam, if it were done using pre-stressed concrete, would be lighter, because I'm now using pre-stressing. The beam to deliver the same performance of, say, deflection or achieving a certain, crossing a certain span, would be much smaller when it came to steel because steel is much stiffer. And you can notice here that by the time I come down to ultra high performance concrete, I can start matching what I get from steel. So with processing now, I can improve the performance to the point that I can start catching up the mechanical performance with steel. Mechanical performance of concrete can start matching what I get with steel. But of course, I also get all the added benefits of durability. So this ultra high performance concrete does not corrode. So it's not going to rust when it's put in water. And it has a much higher, very superior durability characteristics compared to this regular reinforced concrete. That means it will last for a very, very long time. Just to show you a typical ultra high performance concrete mix where, of course, now we are engineering the material. So in this ultra high performance concrete, we don't use coarse aggregate, we use a lot of fine aggregate. One needs to use a lot of fine materials like ground quartz and silica fume. And of course, there's a very heavy requirement of processing. Processing is very different, or the way it's mixed and placed is very different compared to conventional concrete. What can be done? Ultra high performance concrete has become a reality. So this is a bridge that's basically built with ultra high performance concrete. In fact, it looks like a steel bridge, but it's actually made of UHPC. Now, the major reduction that I can get in the dead weight allows me to basically reach an average factor of 3, which allows me to create very slender forms. I can achieve 1:30 slenderness ratio with this material, which is conventionally only possible with steel. And of course, this material now also has this added advantage of very high durability, which means it's going to last for a very long time, leading to a sustainable So with that, I'd like to conclude and open the floor for questions. And just to reiterate, my whole talk was on achieving sustainability by ensuring performance from the material. We engineer the material to deliver on the performance, both in the during placement, while I'm placing the concrete, and when it is in service in the hardened state. So with that, I'd like to thank you for your attention, and I can possibly open the floor for questions.
Yes, sir. Thank you, students. If you are having any questions, please put it in the chat box. Any questions, you can put it in the chat box.
Gopal sir?
Sir, yes, sir.
Sir is able to listen me?
Yeah, I'm able to listen to you.
Sir, myself Lenin actually, I'm the professor from the civil department, EASWARI College. I just want, sir, one feedback I just want to give you here. It was one excellent presentation actually. I'm completely overwhelmed by your presence. Thank you, sir. Thank you.
Thank you. Thank you.
Thank you, sir. K.V.L. Subramaniam, sir. We'll wait for 1 or 2 minutes to complete the session. We'll wait for any students are asking any questions. We'll wait for 1 or 2 minutes. Dear students, you are having any questions, please put it in the chat box, please. ME students, you can feel free to ask questions. Sir is ready for giving an answer for that one. Okay. Thank you, sir. K.V.L. Subramaniam, sir. Wonderfully explaining all areas of concrete, covering self-compacted concrete, high-performance concrete, ultra-high-performance concrete, and everything through your wonderful speech. So, people, the students coming for doing the projects and getting the knowledge about the concrete area, what you have enriched over here. Thank you once again, K.V.L. Subramaniam sir, being with us and accepting our invitation to part of our international program and delivering a wonderful keynote speech. Thank you once again, sir. Thank you.
Sure. Thank you.
So thank you, sir. Thank you for being with us in ICACC 2021 and also for being with us in SRM EASWARI Civil. And for a small instruction to the all participants. So for this two keynote sessions, we'll just sharing you the feedback link in the chat box. So kindly fill that feedback link. Kindly fill that feedback link here, and then you can leave. So after getting this feedback link, you can leave. So I'm just sharing the feedback link here. Gopalakrishnan sir, actually I can't able to send it to everyone. So I send it to you. So please share it in common chat box, sir.
Okay, sir. I will. Okay, I'll put it, sir. Okay. Dinesh sir, you can send it by WhatsApp also, no problem.
No, sir, I sent it in here in the group itself. In that Cisco WebEx itself, I sent it.
Sir, kindly send it through WhatsApp, sir, please. Dinesh sir. Dinesh sir. Okay, sir. Thank you, sir. Thank you.
Thank you, Dr. Gopal. Thank you, Danish. Thank you all. I
Yeah,
will leave. Thank you.
yeah, thank you, Dr. Mohammed.
Thank you.
Thank you.
I will leave.
Thank you. Thank you.
So it is shared, sir. It is shared here in chat box.
Yes, sir. Yes, sir. Dinesh sir. Dinesh sir.
Sir.
Formally we will close it, sir.
Yes, sir. That's it.
Yeah, you can say a few words and formally we will close it. Dear participants, next session will be at 1:30 p.m. The main conference keynote speech by Engineer Hemant Gar, Principal Structural Engineer, Petrofac International Private Limited, Sharjah, at 1:30 p.m. All should attend the program. Okay. Hello, madam. 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 அனுப்பிட்டேன் மேடம். பரவாயில்ல, ஒரே ஒரு டீ தான் மேடம். வேற எதுவும் வாங்க சொல்லல, டீ மட்டும் தான் வாங்க. அப்படியே 11:30 மணிக்கு சரி சரி சரி, அது நான் ஒரு 10 டீ மட்டும் வாங்கிட்டு இருந்தாரு. ஓகே, 11:30 என்கிட்ட வந்து வாங்கிட்டு போனாரு மேடம். ஓகே மேடம், ஓகே. இல்ல மறக்கல, நம்ம இங்க அவங்க தேடி Dinesh sir. Dinesh sir. நீங்க முடியாது சொல்லிடுங்க. உங்க கிளாஸ் சொன்னீங்க முடியாது சொல்லிடுங்க. 2:45 தான் நமக்கு செஷனே ஆரம்பிக்குது. நீங்க முடியாது சொல்லிருங்கப்பா இன்னைக்கு.